now for the fun stuff. So, yeah. All right. I'm going to talk in detail about this thermal bypass checklist we've been talking about. And all that means is when you're starting a construction project, whether it's new construction or renovation, more than likely new construction in this case, you're going to talk with someone like me, you know, like we were talking about before. We can actually save you a lot of headaches when it comes to building these things because we see all the common problems. And I'll point out some of the pictures that we show on here on some of the common problems we see. And before we even start on that, I want to say we do a lot of renovations on existing houses. So the pictures you see in here of the stuff it says to fix in these thermal bypass checklists, I see them every single day in existing homes. And once they're in the existing homes and everything's buttoned up and everything, it makes it extremely hard to fix these problems. That's part of why these things are so important when you're actually building a new home. A lot of the slides and the pictures and everything I've got from my presentation are from the thermal bypass guide, which is available online. It's like an 85-page manual, so it's a lot of stuff, but it's fantastic to walk you through step by step on this thermal bypass guide on some of the specifics. So, all right, so HERS rating system, what does that mean? We've kind of covered a lot of that. It basically means we talk before you start constructing. We'll give you a basic model that we say this is based on what you've told us, this is where your HERS rating is going to be if you do everything right. The second step is we come out and make sure that the insulation's in place where it should be, all of the thermal bypass checklists that we're going through, everything's secure on that side. And then at the end, we come back and we just test everything. We make sure everything's up to speed where it should be. These are some of the other things we're going to talk about. Like I said, go to the website to get the guide. We're going to talk about what an air barrier and thermal barrier are and how you align those. And I'm going to show you some of the common construction problems that we see. We've pretty much covered a lot of what HERS is. I think we kind of beat that one to death. But you basically get a number at the end of the project. Right?
Is this ResNet software the same as the ResCheck and ComCheck?
No, they're different. So that's a good question because they're very, very different programs. ResNet software, it's called RemRate. That's the name of the software. So ResNet runs the HERS system. They develop the software, but definitely don't confuse those different things because they're all different. So. All right, thermal bypass checklist. Checks to make sure the air barrier and thermal barrier are aligned. And like I said, before you start drywalling and things like that, I need to see that insulation and make sure that it's installed correctly. I am a real stickler for the insulation. I got to be honest with you, and we'll show some of the pictures here because leaving gaps like this, you've got fiberglass on the walls, you're going to get downgraded immediately because those leave huge energy holes in the house. You'll see some pictures later on here. So, air barrier and thermal barrier alignment. This picture up here is, I always call this the fiberglass picture because it's pink and we all know fiberglass is pink, right? So, air runs right through fiberglass. Fiberglass is not an air barrier. So, if you're just putting fiberglass up there and it's not sealed behind it, there's no house wrap or anything like that that's actually helping create an air barrier, that means air from the outside here can just blow right through that fiberglass. Where I see this a lot, especially is in the old homes that are balloon framed. You'll see it blow right down from the basement, right up through any fiberglass that might be in there, right up through the attic, because it's just a giant hole that runs right through that. It crushes the energy bills. I mean, it just makes, you can see huge differences in fixing that problem. So we don't want to see that in newer homes. So what that means is you've got to put an actual air barrier on the outside of that insulation. Pink fiberglass will work just fine. I'm not a huge fan of pink fiberglass, by the way, so if I'm picking on anyone who loves pink fiberglass, I apologize. But pink fiberglass will work just fine if you've got an effective air barrier on the inside. things like the foam insulation, open and closed cell, those type of things, they work as both an air barrier and a thermal barrier. So they actually work pretty well for both things. So when we're talking about aligning the whole process, we're basically drawing a line around the entire outside of that conditioned area and saying, where are the holes at? So if you've got insulation all the way up to here and you leave this corner exposed, you haven't got that alignment correct when we need to fix that problem. So this is all part of planning and making sure that you don't leave any, large gaps or anything along the envelope. So, what makes up effective insulation? We're going to see some actual real world pictures of this, but this is what I'm talking about, where you have these gaps, you don't quite have enough fiberglass, so the guys just sort of make it work and they just try to stick it in there, or they stuff it around like a utility box of some type, electrical outlet or anything like that. Compressing fiberglass makes it next to useless. It actually is, it's actually amazing if you compress it just a little bit, it takes its R value down to next to nothing. So it's very important that this doesn't happen nor this.
You're saying that fiberglass itself doesn't stop airflow anyway, so what's the difference?
We're talking about thermal insulation here. So when you have cold air out here on the outside, it's going right through that, because it's going to go through the path of least resistance. And the same thing, actually probably on this side, it's going through here. It's going to go through this weak thermal place.
So that's not a fiberglass example in that picture, that's pretty.
This still can be a fiberglass example, but we're talking about two different things. Air barrier and thermal barrier are the two different things. So we're trying to get those aligned. And in this case, this could be an air barrier and a thermal barrier problem. But specifically, when we're talking about these gaps and voids, we're usually talking about thermal barrier problems. So a couple of examples here. This one, see all the time, because, and it's not anyone's fault. It's just, guys, construction workers in general don't know that this is wrong. They don't know that this is a problem. So it's up to us to, sort of educate you guys as the constructors, saying, hey, let's work on these kind of things. Likewise, this little gap down here, I don't know if everyone can see that, but that little gap right there can cost serious money to that homeowner. So it seems like a stickler thing to you, but when we actually put that into models, you're talking, tens if not hundreds of dollars a year from that silly little gap right there.
We got that pipe. The pipe's gotta be there, how do you?
I'll show you an example in a second. One of the best things is to not use fiberglass, but I'll leave fiberglass alone for a little while. So, these are some examples of some effective insulation. You see it's nice and uniform and solid. There's no gaps throughout any of this. I think this actually might be dense packed right here, and it's just it's been closed in. So it's but the key is that it's nice and uniform. There's no actual issues going on.
You were using the terms of grade 1, 2, and 3. So that's it.
This would be a grade 1.
Grade 1.
This is a great example of a grade 1. If I saw, let me go back to this one. If I saw that one, I'd probably downgrade that to a grade 2, and this may actually be a grade 3 situation right here.
That was my point before, that shouldn't pass inspection.
Right. That actually is true. This might actually pass inspection.
No.
Well, you're a much better guy than some of the people I've found. Alright, so, like we were talking about, spray foam insulation works very well to go right around those pipes. And this is actually the example of the blown-in insulation, where they sprayed it in and they just cut it down. So those are both good options of air barrier and thermal barrier at the same time. So if I'm going too fast with these, there's a lot of information to get through here. Like I said, most of it's in the guide, and you can ask the questions.
Quick question, if you did that flown and then shaped, that last one right there,
Yep.
would that negate the need for house wrap?
No, it would not negate the need for house wrap, because house wrap is also your moisture barrier from the outside, and these don't count as moisture barrier, so you would still need that house wrap.
In your example there, though, how do you fix the thermal
is some thermal bridging across these. There's a couple different ways to do that. What you're talking about would be a much lower ERS rating than what we're talking about. There's, you can actually do double stud walls, which actually take the, you know, normal studs are like this, it kind of takes them like this and makes it a lot longer. So you don't have that thermal bridging across the wood itself. And there's another way, and I can't think of it right off the top of my head, but there's a couple different ways.
Foam skin, that would be another one.
Yeah, there you go, that's what I was saying. Exactly.
What did you say? Oh,
No, foam skin, yeah.
Yeah, you basically just put some sort of insulation on the continuous insulation across those studs. So when I look at this infrared camera, I'm probably gonna see those wood studs right there. But, for the purposes of what we're talking about for the stretch code, that's within our spec, if you wanna call it that, so. All right, attic eave baffles, this is, I see this a lot in older homes. Don't see it too much in newer homes. But basically, you have to seal the edges here. There's a soffit vent back there somewhere, I'm sure, back in this area. You have to seal those areas, because especially if you, that kind of actually looks like perfect, but we'll assume that it's some sort of blown-in cellulose here. If you have a ventilated attic here, and it has direct access to, you know, the cellulose here, it's gonna blow all of that cellulose away from that. So when I look at this from downstairs with an infrared camera, there's gonna be a huge thermal gap right there. And it's gonna be a big problem. So make sure that, when you're looking in your attic, that the attic edges are sealed and that, those soffits can't get to this cellulose. The most effective way to do that is to put those baffling pieces across the top to direct that air above the cellulose. I don't think I have a picture of
Chris,
this.
has resident weighed in on the idea of foregoing attic ventilation altogether? I know there's an emerging school of thought that says,
I don't know.
skip the attic ventilation, just make sure you've got a well-sealed thermal end.
Yeah, we've actually done unvented attics, but I don't know if Chris has officially weighed in on that. But it definitely is a school of thought out there, and it works. You know, you just have to have a high enough R value basically across the roof line. So, all right, slab edge insulation. This is these are some diagrams of how to put in the rigid insulation underneath the slab work and everything. You guys can take a look at these later. Banjo ceiling. This is a very common thing that I see in existing houses as well. This area right here, this is the banjoist. We're usually looking at it from the basement's perspective, as if this is the basement down here, and this is the first floor. This area is a huge leak point for both thermal and air, depending on the construction. So this area needs to be sealed with either spray foam or it's got an SIP panel example right here. So, very important to do that because that'll actually